Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the transformation technique, and this technique can be used to find the probability distribution, the PMF, or the PDF, probability density of function of any random variable. So basically, this technique here can be used for either discrete case or continuous case. And for discrete case itself, it is going to be quite easy because you just need to make some appropriate substitution. However, for continuous case, there are some simple steps that you need to remember, and this will be explained in the next video with some examples related to continuous case. So in this video, we're just going to look at the idea of applying the transformation technique for a discrete case. Okay. Now, without further ado, let's look at the first example here. Well, we have a random variable x. X here represents the number of heads obtained in 4 tosses of a balanced coin. And you are asked to find the probability distribution of x. Next, using the results obtained, you are going to derive the probability distribution of this random variable y. So y here depends on x. X is a random value, therefore y is going to be random as well, and y here is equal to 1 over 1 plus x. So we can come up with a table to describe the probability distribution of x, because I think that's the easier method. I mean, you know that probability distribution here can be represented either using table or equation or graph, and I think table is the easiest one to do, and that's what we're going to construct right away. So we need to be able to identify first what are the values of x. Now imagine you toss a coin for 4 times. Every time you toss a coin, you get tail. Therefore, the number of heads is going to be, the minimum value is going to be 0. It's because every time you toss a coin, you get tail instead of head. So 4 tosses with 4 tails, therefore the number of heads here is going to be 0. Of course, you may get 1 head or 2 head, 3 heads, and maximum number of heads is going to be 4. Well, you can imagine if you toss a coin, every time you toss it, you get head. Therefore, the number of maximum heads is going to be 4, up to 4. Now, our next job is to find what's the probability of each value here. And of course, the basic way or the easiest way to try to picture the whole thing is by using a tree diagram. But in this case, because we have 4 stages, therefore the tree diagram is going to look slightly bigger, and it is going to be a bit tedious to try and find the probabilities of all those in such ways. Okay, so what we're going to do is we are going to consider what you have seen in the binomial distribution function. Oh my god, excuse me. Well, as you can see here, this example is actually a binomial experiment where you repeat the process of tossing a coin for 4 times. So here is n is equal to 4, and the process itself is independent, and therefore you have the same probability for a balanced coin, which is equals to 0.5 every time you toss that coin. Okay. Based on this, we have seen that the binomial distribution function looks like this. We have this one here, and that can be further simplified if you substitute n with 4. So here we got 4. What is p? P is 0.5 in this case. What is 1 minus p? Also 0.5. N minus x is 4 minus x. Okay. Next, what we can do is we can combine 0.5 here, the two of the two of them here. So it becomes 0.5, and the exponent part here is x plus 4 minus x, which is just to the power of 4. Okay, so this is the simplest form. And in order for you to find the probability, what you need to do is you just need to substitute the values of x. So when x is 0, f0 is going to be 4 and 0, 0.5 to the power of 4, and the result here is going to be 1 over 16. X is 1, then f1, the probability of getting 1 is going to be 4, 1, 0.5 to the power of 4. The result here is 4 over 16. This is what you will get. X is equal to 2. Again, you just substitute the value of 2 into this equation. We have 4 to 0.5, and the result of this is going to be 6 over 16. Well, you have to repeat this process for the next one, and you will get these results, 4 over 16 and 1 over 16. And just make sure that you try and add them up just to see whether all the values here are correct, and the probabilities that we add up here should be equal to 1. Okay, therefore here is the probability distribution of x expressed in terms of a table, and I'm going to use this result here to obtain the probability distribution for y. And as I said earlier, this is going to be quite easy because you just need to do appropriate transformation. It is not that difficult. Okay, now the probability distribution for y, we can begin by identifying what are the values of y. When x is 0, you substitute into this, y is going to be equal to 1. When x is 1, y is going to be 1 over 2. When x is 2, y is going to be 1 over 3, and well, you get the idea. So for this one, when x is 3, y is 1 over 4. When x is 4, y is 1 over 5. And for the probabilities of all these values here, we can just take the probabilities that we have already identified for x. Okay, for example, when y is 1, 1 happens because x is 0. x0 is supplied right here in this equation. Therefore, the probability of that must be the same. So here we got 1 over 16. Following this similar argument, similar idea, the probability of 1 over 2 must be the same for this probability, which is 4 over 16. So basically, we're just going to use the result that you have seen for x. Okay, there you go. And maybe we can make it look nicer if you arrange it in terms of ascending order. So arrange these values of y in terms of ascending order. So that's what I'm going to do next. It's going to start with the smallest one, 1 over 5, 1 over 4, 1 over 3, 1 over 2, and 1. And I'm just going to, write down the probabilities associated with all these values. So for 1 over 5, it's 1 over 16. So just write down. 1 over 4 is 4 over 16. And so on and so forth. Okay. So this is the final result. This is the probability distribution for this random variable y. And we are done. Okay. Right, now let's look at this example here. We are going to derive the probability distribution for this random variable, and this random variable z here depends on x, and we're going to use the same setting as described in this example here. Therefore, we already have obtained the probability distribution for x. Okay, so therefore PMF for x is given in this table. So we have x 0, 1, 2, 3, and 4, and this is the probabilities associated with it. 1 over 16, 4, 6, 4, 1 over 16. Okay, so this is the probability distribution for x. We're going to use the result in order to get the probability distribution for this guy z. Okay, again we're just going to do a simple transformation. Okay, so this is the value for z when x is 0. When x is 0, sorry, this one. Therefore, z is going to be negative 2 to the power of 4 is 4. And the probability of that, we're just going to take this probability, 1 over 16. Okay. Next, when x is 1, so negative 1 to the power of 2 is 1. And the probability of getting 1 is the same as this one, which is 4 over 16. Yeah. Right, next, when x is 2, z is going to be equal to 0. So 0, and the probability of that is just 6 over 16. Next, when x is 3, 3 minus 2 is 1, 1 squared is 1, and the probability here is 4 over 16. And when x is 4, 4 minus 2, 2 to the power of 2 is 4, and the probability is this one, 1 over 16. And we need to simplify this table so that we have just the numbers that are not, repeated. For example, we need to combine this result here with this one with this one. Okay, and I'm going to arrange it in ascending order. So here we have z can take values such as 0, 1, and 4. If z is 0, the probability is 6 over 16. If z is 1, then the probability is going to be considered for both of them. So it is 8 over 16. And when z is 4, then the probability is going to be 2 over 16. As always, make sure when you add up these probabilities here, you should be able to get that equal to 1. Okay, so this is the final result for this one. So this is the probability distribution for z, a new random variable that depends on x. Okay, thank you very much for watching, and I'll see you in the next video.